Okay, so today we will learn how to plot a refrigeration cycle on a pressure enthalpy diagram. And to do that, what we're going to need to draw some lines on the pressure enthalpy diagram to represent a typical refrigeration cycle. And in today's example, I'm going to use a medium temperature application. Okay, and I'll make my line a little finer here. And we're going to need several lines here. So I'm just going to clone a couple of these to get us going. And what I want to do is I want to plot a refrigeration cycle representing a typical refrigeration system where, okay, medium temperature application, if we're going to have a refrigerated space and maintain a space temperature of around 35 degrees Fahrenheit in the space, then we're going to have to be evaporating our refrigerant at around 20 degrees Fahrenheit so that we have roughly a 15-degree temperature difference between the evaporating refrigerant in the evaporator, in other words, the evaporator temperature and the space temperature, so that heat can flow from the space into the evaporator. Okay, this system we're going to be using refrigerant R134A, and on the pressure enthalpy diagram here, you can see that the 20-degree Fahrenheit line is right along here. Okay, and that corresponds to a low side pressure of around 37 psia right here. So this is going to this line at the bottom is going to represent our suction pressure. Now, if we're designing our system to operate at design conditions for New Brunswick, which is design conditions for summer design temperatures for New Brunswick around 85 degrees Fahrenheit, and usually when we have an air-cooled condenser operating at around 80 degrees in an 80-degree Fahrenheit ambient, our condensing temperature is usually around 110, we'll say 115 degrees Fahrenheit, because we're usually condensing the refrigerant at a temperature about 30 degrees higher than the ambient temperature so that heat can flow from the condenser into the ambient air. So this would represent our saturated condensing temperature here of around 115 degrees, say about there, which corresponds to a high side pressure of just under 200 psia, around 190 psi, 190 psia or so right there. So this would represent our high side pressure right here. Okay, now typical operating conditions in the system. Okay, if we are running at 20-degree evaporator and usually we run an evaporator superheat of about 10 degrees. So this line would represent a refrigerant boiling in the evaporator at a temperature of 20 degrees Fahrenheit. Okay, and once we boil all the refrigerant off in the evaporator, we add about 10 degrees Fahrenheit of superheat to the refrigerant vapor after it's all evaporated, so that by the time the refrigerant vapor leaves the evaporator, it's at a temperature of about 30 degrees Fahrenheit. Right here, you can see these lines of temperature: 20 degrees Fahrenheit, 40 degrees Fahrenheit. So this would be 30 degrees Fahrenheit right here. And then by the time we get to the inlet of the compressor, we're probably running at a temperature of about 45 degrees Fahrenheit right here, because typically we have around 25 degrees of compressor superheat by the time the suction vapor travels down the suction line. couple other typical temperatures. Typically, we're looking, if we're at 115 degrees condensing, we're looking for roughly 10 degrees of subcooling. So that would mean that our liquid line would be running at a temperature of about 105 degrees. So there's 120. So 105, here's the 100-degree line. So 105 degrees would be right about here. Okay. And a typical discharge temperature on a system like this. Usually our discharge line temperature 6 inches down from the compressor runs at about 175 degrees. And inside the compressor at the valve plate, okay, you can usually add about 50 degrees Fahrenheit because the refrigerant at the valve plate will be about 50 at a temperature about 50 degrees Fahrenheit above 175. So 175 plus 50 would be about 225 degrees Fahrenheit, which would be right about here. Now, having done all of this, now that we know our pressures and our temperatures in the system, we can complete the plotting of a refrigeration cycle, okay, by starting from, usually from this point right here, okay, and if we draw a line from the pressure and temperature of the refrigerant vapor as it leaves the compression chamber, and if we draw a line down, we start from that point, and we draw our line down to our bottom line, and we keep this line parallel with the lines of constant entropy, then we'll have a line here that represents our compression stroke. Okay. Also, we can take our other line, if we can take a line and we start from a point, okay, where the pressure and temperature of our liquid line as it enters the metering device, and we draw the line straight down from here. We now have this line that represents the process where the refrigerant goes through the metering device. So here we have our cycle plotted for this system, representing, okay, what we have here is a starting point where we start to boil refrigerant in the evaporator. We boil off all the refrigerant in the evaporator. We add some superheat to the refrigerant in the evaporator, and the gas leaves the evaporator at this temperature. The gas enters the compressor at this temperature, and you notice that from here to here, okay, the refrigerant gas picks up more superheat as it flows over the motor windings in the compressor and enters the compression chamber. Here we have our compression stroke here. Then we have the desuperheating of the refrigerant vapor, the condensing of that vapor, and the subcooling of the liquid in the condenser. And then here we have a line that represents what happens, the re-expansion of the refrigerant as it travels through the metering device. So here we have plotted a typical refrigeration system on a pressure enthalpy diagram.